mean, let's just get right into it then. So, I'm not sure if you're familiar with the format, but these are going to be an hour long. We're going to be, we usually do introductions at the start. We're going to skip that. We're going to do it at the end if you're interested, but we're going to get to about 45 minutes to 50 minutes of working time. Okay.
Hmm.
And then the last 10 or 15 or so will be for feedback and for any questions you might have for me. How's that sound?
Okay, sounds good.
Okay, cool. So these problems I'll dictate. You're free to, of course, pause me, take notes in the code. Just write down. You can just write comments or just write in the coder pad, etc.
Okay.
And we'll just go right in from there. So the first question is going to be a variation of valid palindrome. So do you know what palindromes are?
But the same forward and
Yes,
backwards?
they're the same forms and backwards. Okay. So we write a function to check if a string is a valid palindrome, but there are some special conditions that we're gonna have. Okay, so the first condition we're gonna have is that we ignore all non-alphanumeric characters. So if it's not alphanumeric, it doesn't count. It's ignored. Okay.
Okay.
The second thing is that it is case sensitive. Okay, it is case
Okay.
sensitive. It's case sensitive. Okay, so I'm gonna just start with just these two conditions, and then we'll build on that.
Okay. So same forwards and backwards. Includes all alphanumeric characters and it's case sensitive. Oops. And the string can be any length.
Yes, that's right.
So I assume since it's a we want to check for a palindrome. We want to have two pointers, one at the start and one at the back. And then we compare the characters, but if either of the characters are non-alphanumeric, we'd move the pointer either the front pointer to the right or the back pointer to the left. And it's case sensitive. If I just compare the characters directly, it should be fine.
Okay.
First, I probably get the length of the string. And then initiate my pointers. Okay, I'd want to compare the characters. Okay, if they're ever not, oh, I need to check what they are first and move them. Oh, and I'm returning a Boolean, right?
Yeah, that's right. Return boolean. Yep.
Okay. And I still need to make sure I increment, decrement, and then make sure I take care of the alphanumeric. To keep moving L and R until they're valid alphanumerics while making sure they still are in bound. I don't remember the Python function to check. I think it's is L. Oh wait, this has. Can I just keep typing until I find that one?
Are you
the
looking for
library function.
what function?
Is alf num? I know there's a Python function that can.
Yeah, it's alnum. You can use that.
It's alf num. Okay, thank you. Let's take it. Okay. So I need to keep going until I need to make sure it's. Oh, so maybe I should do it before.
Are we thinking about what to have, like how to handle the situation where the current letter is alphanumeric or is not alphanumeric?
Oh, is not.
It's
I
not. So
just
you
wanna.
have
I'm trying to move them
okay, and what?
move
So
them
if
both
it's
until
not,
they're
what do you
both
want to do?
valid. Sorry?
Well, so if it's not alphanumeric, what do you want to do?
I want to skip it. I want
Okay.
to move the either L forward or R backwards, but I also want to make sure that this while loop is still maintained, or if it'll leave if it's. Oh, actually, I can just break after, I guess. I also need to do it for R. And I still need to make sure this is maintained. They be the same, yeah. Okay, I'm not sure this is right, but let's try an example. Did I ever compare them? Oh, I did. Same. String. Just give it an easy without anything first to see if it'll work.
Okay.
Initialize with this. Oh. R would be 3, so less than 3. Well, this is correct. Well, it's not. No, but it is, so this would pass, this would pass. So L is greater than. And then I'd compare them. Oh, I need to increment them still. Okay, so this passes. So increments to 1 and 2. Then it compares B and this is fine, this is fine, this is fine, it's fine. Fine, and it returns true. So a more difficult example with some symbols in it.
Could you just quickly give me a voiceover for what the
Sorry.
goal is, what the current test case?
Oh, I just wanted a test case to try with some non-alphanumeric characters to see what happens.
Great, makes sense. And what would what would the correct return be for this string?
Oh, actually, it's true, I guess, because we ignored the.
Okay.
Okay, so let's see. If A and A, this is fine. This is fine. they're not the same, so I increment and decrement them. Oops. And then while it's not, this tries to move up, this moves down. So now this isn't true, so it returns false. Oh, that's a problem. I wanted to ignore it, but then
So what's going on here? So we're looking at the case
so
we're
we have an
comparing
issue with
L equals
yeah.
1 and R equals
So we know that
2.
they're not the same, but we tried to ignore it by moving it up and down. But then the problem is that since my 2 pointers are out of range, it returns false. But I actually want it to return true.
Right. So why does this return false?
Why does it return false?
Yeah.
Or,
like what? Like obviously, I mean, it turns out because you said it turns false. But why do you think if the left pointer is further right than the right pointer, it should be false?
so it doesn't mean it's false. I guess it just means I'm done. I don't need to compare any more values.
Yeah.
Case is it? Oh, since I haven't returned false already, then I think I can just return true. Because I checked every value. I've passed the point. Oh, I think that's just.
Okay.
Okay, so in this case, it's returned true. Just quickly test an odd length. What should happen in an odd length? It would be the same until they both hit this character when L equals R, so it's still going the loop. It increment, decrement, and it end here. Case sensitive. What happens if there's no? What should an empty? Is an empty string considered true? Valid palindrome?
That's an interesting question. I would say yes. I would say yes, just because there isn't the negative condition being met. So I would say yes, an empty string would be considered palindrome.
Okay, I don't have to take care of that case then. Huh. I'm not sure where to proceed from here.
Does that change anything about the algorithm though? Like if you had, let's say, a string of only symbols, would
If
that
I had a string of only symbols,
would that be a problem?
that'd be a problem if I had a string with only symbols. So a string with is the expected value for that true or false? Because I ignore them all, and would it be considered an empty string?
Previously said, if empty string is considered a valid palindrome, then
Right.
All symbols would also be valid, as it would reduce to an empty string essentially, right?
Okay, it reduced to empty string. So in that case, these pointers would keep going. No bound. This would go and this would fail after it passed R at the end. Okay. Because I didn't catch the case where I didn't consider that this would not end early. It could actually just keep going, so I need to add a bounds to both of them.
Yep.
And in that case, this would stop. This would stop at n. This would stop at -1, and then it would be able to return true in that case.
Okay. Looks pretty good right now.
Uh-huh. I'm not sure what's next.
Okay. Are you happy with this solution?
Yeah.
Okay. Okay, that's chill. Okay, let's add another condition then.
Okay.
Okay, so, well, actually, before we go to a condition, let's just quickly go to the time and space of this function, please.
Okay.
Yeah.
So time. It's just going through the entire string, so it should be O of n, and we're not using any extra space, so it's constant.
Okay, sounds good. All right, so third condition. The third condition is if it's not a palindrome, you can remove up to one character anywhere to try and make it a palindrome.
So I would still return true.
So it's still true or false.
Oh, so if it's possible.
If it's possible to, if it's not a palindrome, if it is a palindrome, you return true. If it's not a palindrome, you return true if you can make it a palindrome after removing one character anywhere.
Oh, that's an interesting condition. Remove up to one character anywhere to try palindrome. Oh. Well, the brute force solution would be to remove it at each and then call this, but I think we can do better. It's not a palindrome. I can remove up to one character anywhere. I feel like we need to rewrite this.
I mean, we can start by just drafting this simple solution.
Okay.
Right. So you had an idea there.
Right.
Why don't you just quickly bang that one out real quick and we can talk about that.
Okay. Okay.
So you can keep this
My
function
other-
around, right? So you
Yeah.
might still have use just keeping this around. You might just want to make a separate function to do this.
So if it's not a palindrome and we try removing every, and we try calling this for every string that has one less character. Okay, then we return false in that case.
You might just want to make this another top level function.
Oh, no wonder grayed out. Wait. How can I remove a character? Oh, I can slice. Slice it. I need to call this.
Well, it might be a bit easier to think if you flip the condition. So like, if valid palindrome, just return true.
Then I can just return true, and then
yeah, just get out of that branch. Yeah.
Otherwise, I can I want to slice this. Wait, I want to remove the character. Let's see, how can I remove the character?
So you're removing index I, right?
Right.
Okay.
So I want to get, this will go to, does not include I. And this does not include I wanted to try it at every. I can move up to one character and try to make a palindrome. So I want to try to make it a palindrome. If any of these work, then I can return true.
Mm-hmm. Okay, cool.
I guess it's time to test it. This one, the original one, is not a palindrome.
Yep.
Return not there. And then for iron range, try to remove. Okay. We'd have this left. Then palindrome. No palindrome. Remove the B. At the very end, it'd be a palindrome, and then it can turn true.
Mm-hmm.
And if none of this, if the original wasn't a palindrome and removing a character at any place is in palindrome, then return false.
Yep. How are you feeling about the current implementation?
It should work,
Okay.
but
I think it
not
should
sure
too.
if it's optimal.
That's okay. We can work on that. But before we work on improving it, why don't you? Well, why don't we go through the time and space of this one, of this new problem?
So this time um, we have a for loop here, which
Okay.
goes in I range n. So we have n, and then the original checking was n, so n
Uh huh.
squared.
Okay.
And then we're still not using any more space, still constant space. So yeah,
So
constant space.
constant space. Okay. Okay. Let's work on improving the time here. Okay.
Yeah.
So I mean, as you have correctly, formed some intuition about, this is not optimal in terms of time, right? Um, let's think about this case over here. That you have. I'll delete this one. Okay. Um, right. So as a regular, and for the sake of this argument, I'll just get rid of the symbols. The symbols don't matter here. Okay.
Okay.
So, you know, the main thing here is this is obviously not a palindrome, but we know that if we remove one of them, they will be. In fact, I'll put it over here
Right.
so it's easier to do some iteration. Okay. So the thing is, let's say that you have that you remove a some letter. You can check if it's a palindrome. That's fine and dandy. But one thing you might notice is that your palindrome checks your palindrome twist my words your valid palindrome function checks the entire string no matter where you remove the character, right? So if you imagine like a larger string, right? Like this is hard to do: A B C D E F G F E D C D A, right? I hope that's right.
Mm-hmm.
This is a palindrome, okay?
Right.
And if I add like something over here, like an x, if I remove x and I'm in like I equals what is that, like 5, right? And remove it. So this is the input, right? This becomes the input to the valid palindrome. You still check all the previous pairs, right?
Right.
You still check the previous pairs because this function has no context about what was removed. Does that make sense?
Right. Right.
Okay. So here's some intuition to help you along. Let's say this is just obviously a fake example, but let's say we have this x over here, right? Is there a way to tell this function, hey, up until x, everything is good, right? Like up until like this is good, and then this is good, right? So if I give you x, let's say let's say for example I give you like index, some removed index, right? Removed index. Please start the string from s from index. Oh, just right. It's removed from here onwards, and then of course you would also shave it off the end, right? Like, is there a way you can do that? And the reason I'm giving you that intuition is because if you can do that, you guarantee that the cumulative search of the valid palindrome it might be less than the actual total amount, right? The total
Right.
string every time. So if you can reduce the search space every time, you can improve the performance there. So what are your
Right.
first thoughts when it comes to this sort of optimization? Do you have an idea for what you might want to change? What and by the way, I'm just you might not actually want a parameter here. For example, you can actually just pass in the string that's already shaved, etc. It doesn't really matter what you do here, but
Right.
that's an idea. Right. Do you have other ideas for how you might want to accomplish this?
That sounded pretty good to me, honestly.
Okay. Okay. Well, why don't you give it a shot and see where you get.
Okay. So essentially, we'd pass in what index we're up to, and then oh wait, what was the point of this?
I'm gonna actually hop in here and give one more kind of direction here.
Uh-huh.
This loop over here, I mean, it's fine, but I think
Yeah.
it's better to be a bit more explicit. Okay. And what I mean by that is, can we, instead of just blindly iterating over everything, which we do need to do anyways, but can we think about the iteration in terms of I or L and R already? Right. And what I mean by that is, right, um, if if let's say no, let's say our example here, and we do the valid palindrome check, right? Like, if we know that this, right, so the first 5 letters, I'll write it underneath here.
Yep.
Right. Let's do it this way. That didn't work. EDCBA. We know that the first 5 letters match, right? Like you could check that, right? You know that the first 5 letters match, and so you know that you never want to remove any of these 5.
I know I never want to. Uh-huh.
Right? So we actually only want to consider removing a character if L and R, which is X and F in this case, if they don't match. Then we want to remove either X or F. Right?
Uh-huh.
So I would suggest you actually write a little logic here to check. You should only remove, like, don't blindly remove. Don't remove without any condition. Only remove
Right.
if the L and R don't match. Right? If they match, you never want to remove it, right? Because they match.
That's true.
So take that into consideration.
Check L and R. Okay, so I can either move this one or move R. Huh. Wait, I think I'm just blindly following. I don't actually understand what I'm doing.
Okay.
Okay, I understand the logic here that we only want to check if
Yes.
they match, or else we're just checking characters pointlessly, or we're calling this pointlessly. I also understood that.
Right. So we have our guy over here. What the heck is this indenting? Okay. So here's the situation. Okay.
Yep.
We have our string, and we need to check 2 strings. Okay. So we need to check is valid for. So we remove X. So that's going to be F FGF. I can't type FGF, right? And we also need to, but we don't know that's right? Obviously, we can look at the example, but in reality, we don't know if it's right. So we also need to check. So this is going to be remove L, right? So this means this, and we need to remove R, which is valid for XFG, right? Like if you delete these 5, which we don't want, right? Because those are correct. So we want to either remove the right one or the left one, right? If you remove the X, you want to put in XFG. If you move the right, then you'll put in XFG.
Right.
Right. So you actually have 2 conditions when you remove. When L and R don't match, there's 2 possibilities.
Right.
So you need to figure out how to pass these 2 strings into the function.
Right.
And I'll get rid of the removed index because that's actually really not needed here. Right. So can you figure that out? I'll put the string over here for you again.
For this one, we start at L.
Right. So L is at X.
And where do we end? At F. Just make R. L here. What is my R? R should be my F.
Do you want to write out exactly what L and R equal in this case?
Yeah.
So what is this equal? So we just finished A, B, C, D, E, right? Our L is at X. What is that? What index is that? Yeah, 5. Okay, and what is R? Yes, 8. Okay, I agree. They don't equal. And then we want the first one. We want this to be remove left, which makes it FGF. When this is remove right, which is XFG. Yes. Okay, so what index is this? F is 1 more than L. Right? L is at X, so we want this to be L plus 1. Right? We want to do 1 more. Start at the 1 more.
Right.
Right? Start at X6. And R equals 8. 8 is currently at F. Is that acceptable?
It does not include that.
Yeah, so we need to. Okay. And in this one, right, we don't want to remove L, so we want L to start right where it is because it's already at X. And then where should R be? R needs to point to
G.
To the G. Yeah.
So it should be at F because it won't include. So 8 because it won't include the last one.
Yeah. Okay.
Let me just verify. So if not the same character. So if they are the same character, we just increment the pointers.
Yep.
Move the pointers, and then we finally reach this. And then we realize they're not the same. So we call it this. Not, we move them up again. Sorry, I'm like checked out. Like a little
Yeah,
stressed.
yeah. I mean, I think that the indexes here are right. Right. We have the FGF check. We have the XFG check. These are the two strings that we needed to check because again, right? If you're at an impasse where your L and R, where your L and R aren't equal, you have to check both. And in
Mm-hmm.
both cases, you are checking that, right? And so
Yes.
the original logic we had, which is that because we are no longer checking the entire string every time in the valid palindrome call, why is there a comma there? We're able to essentially save the time complexity there as we never double check
Right.
an index,
Right.
right? Okay. So given that, can you walk me through the time and space in this case?
Um. Okay. Let me just. This is n. We're not double checking anymore. It should just be O of n then.
Okay, for time.
Yes.
Okay, and what about space?
We're still not using any extra space, so
Mm-hmm.
it's constant.
Okay. So you said in time. Okay, cool. All right. We're almost at time, but I did so we don't have time to do another follow up. But I
Yeah.
did want to ask another follow up, and
Okay.
see if you know what kind of intuition or what sort of ideas that you would explore if you had more time. Okay.
Okay.
So for this follow up, in addition to just being given S, you're also given integer k. Okay. And k represents the number of characters you are allowed to remove, up to k, 0 through k. You can remove 0, you can remove, if k is like 5, you can remove 0, 1, 2, 3, 4, or 5 characters.
And
You
then
can remove up to k. How would you adapt your solution, if you would, or would you write a new one, or what sort of intuition do you have for this problem?
okay, so instead of what we did earlier, which was one character, we can
Mm-hmm.
remove up to k characters.
Yep. Do you have an intuition for that? Does a current approach work? Do
Nope,
we need a
because
new
we only
approach?
remove one character.
Yeah.
But maybe we can use some of this part to keep going until we don't match.
Mm-hmm.
In that case, we can remove up to k.
Yeah, so we're thinking about adapting sort of the current solution, at least the beginning of it, with a while loop, as we were thinking.
Yeah.
Okay. Okay, yeah, I think that would be a reasonable start, but because we're out of time today, we'll
Yeah.
stop it here.
Mhm.
Okay, so before we take any feedback, I want to just ask you, like, how do you feel about it? What sort of strengths do you think you show? What were the weaknesses? And of course, I can give a little review afterwards.
Okay. So I get really nervous, and then when I get stuck, it's really hard for me to voice out what I'm thinking because I'm not confident in what I'm thinking. I think that's an issue.
Okay.
Um, yeah,
Yeah.
that's the biggest issue. I just get stuck a lot, and I don't know how to get
Yeah. I
around
see.
that.
Mm-hmm. How I mean, we'll talk about that. That's no problem. About the actual solutions themselves, do you think they're correct? And do you think you're? I mean, let's start there. Like, do you think they're correct right now? Like, how confident are you actually? You don't have to be. You don't have to be sure. I'm just not like because the interview, the mock is over. We're just asking the feedback now.
Yeah.
Like, are you? Do you think they're actually correct or not? I'm not saying they're wrong or right. I'm just asking you. Like, do you think they're correct?
Uh, I'm not confident
Okay.
100% because sometimes when I do it, because when I'm practicing, I
Yeah.
can run it and I can see the test
Yes.
cases, and sometimes I'll miss test cases, so it's
Yep.
really hard for me to tell if I'm missing stuff.
Okay. Is that for both parts 1 and 2?
Uh,
Like
yeah.
this? Okay. Okay. If you had to put a percentage on like how confident you think would it be like 50? Like,
This one's probably like 80 because this one's a
okay.
lot simpler. But this one I actually, because I didn't come up with it myself. I got it basically from you. So
Yeah.
I didn't really, yeah. It's a lot, maybe like 40.
Okay. Okay. Fair. All right. Yeah, we'll talk about that. And then about the time and space, how confident are you about that?
That one should be fine.
Okay.
At least for this one, it's fine. This one, because we're not double checking, so we should only be checking them once, or I think once, yeah. So it should
Okay.
be linear.
Okay. Cool. Let's talk about it. So,
Okay.
first of all, I know you're nervous. I know this is a different sort of performance. That's why we practice, right? Like
Yeah.
that's why we do the mocks. That's why we get
Yeah.
nervous here instead of on the real interview. Now,
Yeah.
I'm not saying we'll get nervous on interview. I'm just saying that you will get nervous on interview. So it's
Yeah.
better you practice it now, how to perform when
Yep.
you're nervous,
Yep.
right? So just to frame the mindset, don't practice to not be nervous.
Yep.
Practice to perform when you're nervous. Okay.
Yep.
So that's a mindset thing. Now, a couple things off the bat. Good notes, right? Good notes. Lay out the test cases or lay out the conditions. That's very good. I would say you can be even better if you just immediately lay out a couple like strings you think might be edge cases, right? Just immediately bang out a couple of those, right? One thing you
Yep.
caught later on was, oh, what about an empty string, right? But you don't need to wait till halfway to ask that, right? Like,
Yeah.
for this case, it wouldn't affect your solution at all if I said either way. But like
Mm-hmm.
whenever you see a problem, so the input's a string, you should immediately go like, all right, what are the string edge cases? Empty string, null string, string with
Yep.
not okay, maybe not this like non-Unicode. Like don't worry about that. But like oh, it's a tree question. Okay, null root, left and child, balanced tree,
Yep.
sorted tree, right? So whenever you hear a problem, you should immediately go like, okay, what's the input type? Great. Here's my 5 immediate questions for edge cases about this input type, right? So
Yep.
that's something you could. I mean, I'm sure you can think of those, but just bang out, just memorize them, right? Strings,
Great.
lists, heaps, whatever it is. Just memorize the edge cases and just bang those out. Okay. You don't want to miss those if they're actually gonna affect the problem. Okay.
Okay.
That's the
Actually,
first thing.
a quick side note. I guess
Yeah.
for the specific case, I asked this question,
Yes.
but I thought that it wouldn't really affect it because either way, I could just check if it was empty at the beginning and then return true or false. But
That's
I
right.
knew
Yes,
it came
that's
out
right.
a little
It's
later.
true. But for strings, there are some other things you might want to consider. In this case,
Great.
so I would say this depends on where you're at with your Leetcode journey. There
Great.
are some really big sticklers, like people who really care about the various edge cases. Um,
Great.
for example, you might be asked how many characters is an emoji. If you think of an emoji on various things, you think it's one character. Actually, emojis are typically 2 characters long. Does it matter for this problem? Sort of, because you have to index it. But again, I'm not going to be docking marks there, right? But I'm just saying, like,
I
whenever
see.
you have these problems and these inputs, just ahead of time, just memorize all the edge cases, right?
Right.
So then
Okay.
you don't have to. Like, the goal is that you don't have to think about it, because when you think, you could be
Right.
wrong,
Right.
right? So just don't think about it. Just memorize that. Okay. So that's a little tip there. Again, I agree for this problem, it didn't make a difference. All right, I agree with that. But just as a tip, okay.
Yep.
All right, so moving on. Clarified usage of the is alphanumeric function. Usually they'll let you use that. If they don't, I hope you know regex, or you know your ASCII.
I'll try my best.
I mean, the thing is, okay, like if it's a Python thing, people know. All right, you probably just learned Python for the interview, but generally speaking, though, like you should know a little bit. Like, you should know a little bit
Yeah.
about that, right? At least you should
Yeah.
know how to use a regex engine for the language of your choice. Okay. All right. Yeah. So I mean, the immediate function here, the first one, the first bug, you caught with a prompt, right? So you caught this bug over here that was
Right.
returning false. Caught it with a prompt. Not too bad. Generally speaking, though, for these kind of problems, you want to make sure that whenever you write a condition, you think about a case in your head that triggers that condition and sees for yourself, like, oh, is that what I expect, right?
Right.
In this case, you need a little help on that front. Not too bad,
Yeah.
but you did catch it when I gave the prompt, so that's okay. Um, the overflow over here, again, this is okay. There's a little prompt here as well, but you did catch it, so that's okay. right? But again, in general, right, if you're using a while loop, you got to make sure a while loop terminates, right?
Yep.
That's kind of how it works, right? When you're for
Yep.
loop, those are usually okay. While loop, want to think about that. So again, just a little
Yep.
pattern there. Um, Otherwise, time and space. You said linear time, constant space. That's correct. That's great. That's not the interesting problem. Are there any questions here before we move on to the second part?
Nope.
Okay, great. So part two, removing up to one character anywhere. Um, as a general tip, again, especially when you're nervous, if you can think of a brute force and you can't think of anything else,
Yep.
acknowledge it. Hey, I can only think of the brute force solution right now. I want to just start working on that because I think I can, I think I can implement it pretty quickly. And
Great.
after or as implemented, I'm going to be thinking about how I can iterate and improve on this, and then just
Great.
start coding the brute force one. Because
Great.
what's gonna look really bad is if you sit there thinking about things and you don't come up with something, and
Great.
then you're still going to be coding the brute force. Okay.
Yeah.
So as a strategy, if you can't think of something, if you don't recognize a pattern in the first like 30 seconds, just code the brute force one, and as you're coding it, just continue to think. Like just think about what's going on in the back of your head. Think about like what you might have seen before, etc. And as you do the mechanic, as you actually implement the brute force, that might actually give you some insight about how you can optimize. Okay.
Great.
So as a strategy, don't hesitate to implement the brute force if you can't think of anything else, because otherwise it looks a lot worse. Okay.
Great.
All right. Let me see. Yeah, that was the main thing there. Oh yeah, one thing I had to say about this, which was even before this, like before this, when you just had the brute force, the time and space wasn't quite correct. Um,
Okay.
the time is correct. The time you did, so iterate through everything in square. That's chill. Um, Space is not constant,
Oh.
and the reason space is not constant is because you used a string slice. Okay. When you slice a string and you concatenate it, that uses extra memory because,
Uh.
well, there's various reasons why. But even without this consideration, when you modify strings in most languages, including Python, and basically
Right.
every language you can name, it
Right.
actually copies the entire string to a new string.
Right. Right.
Okay,
Right.
so that actually does use memory, and
Right.
so you would have been using a linear memory there,
Linear. Yeah.
linear memory there, because you would always have at least one string in that you constructed. Okay,
Right. Right.
and that same applies to this solution here, which is that yes, while the time is now more optimal, it's now linear time. The space is still gonna be linear because you always have two
Right.
strings
Right.
open.
Right.
Okay, so that's a bit of a miss on that part. In terms of the memory, I would say that's not too bad of a miss. Like it's very clear where you didn't know what was going on. It's very clear this is just a knowledge issue. Um, so that's not too bad. But do be aware that like yeah, like people do kind of care about that when they
Right.
see
Right.
like oh this person just doesn't know how Python works. It's not going to be like that might, especially if it's like a Python role or something. They might look down on that because it kind of shows that you don't like you haven't really worked much with the language. So a
Right.
little detail there for you.
Okay. Thanks.
Um, Otherwise, what I will say also for the second part was that you did ask for help when you were stuck on the comparison, right? So it gave the hint about how you can optimize it by only searching for a subset of the string every time you do the valid palindrome, right?
Right.
And of course, you can that itself is a hint, but that's like an idea of a hint. That's not really the implementation. So if you get stuck on implementation, hint or not, if you get stuck on it, it's okay to ask for help on that because for most interviews at least, it's pretty clear that that you're stuck, that you don't know what's going on, right? So it is a skill in itself to recognize that you need help and that you should ask for it,
Right.
right?
Right.
So don't think about it in terms of like, oh, if I ask for help, it's done. No, think about it as like, okay, if I don't ask for help, it's gonna look worse. Okay.
Right.
So it's okay to ask for help in those kind of situations, especially because it means that you can carry on and eventually finish the problem.
Yeah.
Okay, cool. Um, that's sort of the overall summary. I want to give any room for you to ask, if you have any question on your side, either about the problem or about maybe more pertinent to this conversation is about like any strategies or any questions you have about being nervous, asking for help, that kind of thing. I'm happy to answer those.
Okay. Just in general, like, what happens? What should my approach be if I've seen the question and I like vaguely remember the answer, but not fully?
Approach being, I mean, there's a couple ways to say this. I would say do the question as best you can, and try
Yeah.
to get to the follow ups. Like,
Right.
I mean, for me personally, if I have seen a problem before where I definitely know the answer, I'm like, oh hey, I've seen this problem before. I know what's going on. Maybe we want to ask a different one. If it's a problem where you're like, oh, I'm not really sure, then I would say just try to do the best you can. But depending on who you are, you can choose. Hey, hey, I've heard this problem before. I don't really know the answer. I forgot a long time ago. I'm not really sure what's going on. Do you still want to proceed with this? I would say most people who are your competition would not disclose that. I'm going
Yeah.
to tell you right now, they won't disclose that. And I know that because I'm an
Yeah.
interviewer. And I know that people have seen these questions before.
Yeah.
But also, generally speaking, it won't really give you much advantage anyways. So,
Oh, I meant more like, let's say I knew what data structure the optimal
yeah.
solution used.
Okay.
But I think it'd be a little awkward if I focused on that out of the blue.
Oh no, I mean that's okay. I mean the thing is do you know that's the optimal data structure because you memorized it or because you actually understand how it works? Right? That's the main thing. It's not a problem for candidates to say, "Oh, this problem, is well suited for a try data structure because it has these properties." That's very understandable. But if you say, "Oh,
Right.
this is very well suited for a try and I don't know why, but I think it is," then that's going to be a problem. Okay, so
Right.
it's not a problem to hone in on the optimal structure, if you can justify it and if you can
Right.
explain some alternatives, like, oh, I would consider using a heap, but here are some optimizations that wouldn't quite work, or this edge case wouldn't quite work, right? So if you can
Right.
if you can hone in on that, that's totally fine. It's only a problem when someone can't explain, they can't explain why. Yeah.
Right. Right. Okay, I agree. Okay. I think that's all the questions I had.
Cool. Well, thank you very much for coming on. Talk to you later.
Thank you so much. All right.
Take care.
Thank you. Take care. Bye.